Hey there, .NET devs. Welcome back to the channel. Today, I want to talk about improving your efficiency in developing IoT solutions. If you've been watching this channel for any length of time, you'll recognize this. This is my Tilt project. We've got a Meadow F7 Feather, we've got a display, we have an accelerometer, and an INA 219 current sensor. If I'm building something like this, there are a lot of challenges that are going to slow me down. One is I have to assemble all this hardware. This one is completely soldered together, so we've got a bunch of wiring that has to happen underneath. You have to have the sensors, you have to do the layout and the design. Oftentimes, when you're building something like this, you'd like to do some quicker prototyping without having to do all of this. So, for those who aren't aware of what this does, right now if I tilt the thing, we get some, movement of the little ball based on just the angle that this thing is sitting at. So we've got a processor that is looking at the accelerometer and then updating the display. It does some other things we can talk about here in a minute, but right now that's what I want to focus on. So how do we improve our speed in developing something like this? Well, first we want to remove the need to do a bunch of soldering and wiring and layout, that type of thing. So we might take something like this. This is an FT232. This one's specifically from Adafruit, but they make some generic ones that you can buy online. What this does is this gives me USB access to I2C, SPI, and some GPIOs. So I'm using this for the I2C bus, and then I have it wired over to the MPU 6050, which is the exact same accelerometer that was on that other device. So then I go, okay, well, now I've got this. I haven't had to do any soldering. I just put some fly leads in here and connected it up. So let's take a look at how we would modify our code for that. It's actually very, very simple. So the application starts up. In the initialize, there are a few things in here, but the important piece that we want to focus on is this section right here. We create the I2C bus for the device, and in this case, the device is the F7 Feather device. And it's going to create the I2C bus. The speed really doesn't matter for our purposes here, but then it takes that I2C bus and some settings and passes it to the app engine. The app engine then initializes the accelerometer. And what it's going to do is it says, okay, well, in these settings, have I had something that overrides the accelerometer? In this case, we're not. We're just passing in the I2C bus. So it creates an MPU 6050, which is that hardware that is on that platform. And then it wires up some events. And that's how we get the translation of the tilt of the hardware to the movement of that ball on the screen. So what we want to do here for the desktop, we take this FTDI expander, and we've got a collection because you may have multiples plugged in. And then we take that and we get the I2C bus from it, and we pass that into the exact same app engine. So then the app engine again creates this MPU 6050 just like it would on the Tilt hardware. So we've got identical application code, and really the only change is our initialization. Instead of getting the I2C bus from the device, we're getting an I2C bus from an expander here. So if we take a look at how that works, if I execute this application, and for the display here, we have a desktop display. You can see that it's the same screen with that ball. I have to hold it a little bit different because I haven't modified the code for the 90-degree tilt. But you can see that I can tilt this, and it causes it to move. So we have identical code that is running using hardware, and the debug cycle here is much, much faster. So if you can see let me put in a breakpoint here. If I start executing this app, I'm at that breakpoint in about a second. If I'm going to the F7 hardware, however, the application has to compile, but then it has to do what's called trimming, where it removes all of the methods and classes from the assemblies that aren't used. It then pushes that over serial to the device, and then that has to get flashed into the onboard flash. That is all a slow process. If you've only changed the application, it can take, 20, 30 seconds for all of that to occur just to get it pushed down. And then even debugging is slower because it has to do communication off board to the remote device in order to set breakpoints and do stepping and things like that. So if we can develop right here on our desktop, it is a much preferable scenario. So that's the first thing that we can do to improve things. But how do we even go faster than this? Maybe I need to order some hardware. I don't have one of these 232s on hand. How can I do development without having hardware? Well, let's take a look at that. Because my application in the settings uses an iAccelerometer, not a specific MPU6050 instance, I can pass in the accelerometer here. So what I can do is I can actually use a simulated one, and Meadow Foundation has simulations for a large number of different types of sensors, current sensors, voltage sensors, that type of thing. But we have a simulated accelerometer. So instead of starting with the FTDI, I can start the application using simulation, and instead it creates both a simulated current sensor and a simulated accelerometer. And then it passes those in via the settings, and then when the app engine starts up, this is non-null, so we end up using that accelerometer. So if I fire it up again, you can see I've got it running here. Now, it's wiggling around, and that's simply because I have it set up to do random walk. So it is just randomly sending data from the sensor in so that I can see that it's moving around. Now, for this, I could have wired up some keyboard keys to actually make it act more like a sensor that moves it left and right. But the thing that becomes interesting here is, what if I have a more complex thing that I want to set up? So what if I have something a little bit more complex like this, right? I've got a display, and let me flip it around here. I have a display that shows me a histogram of the power that is being used here. So the current coming through that, it gives an average and then a instantaneous current. So what if I want to develop this UI? Developing that user interface to hardware would be a real pain, and hooking up a current sensor to this would be difficult because it is really not meaningful. I've got power coming from the USB from the PC running this, and I'm not, running a display and a microcontroller. So whatever power I would actually measure here would be non-meaningful. It would also be difficult to get the split of power coming through that USB. But I still want to do the development of this display. So I can simulate not just the accelerometer here, but you can see it's also simulating this current sensor. So I can do that development of this application, and I have it wired up with the keyboard and the tilde swaps between those. So that that is simulating that button that is on the hardware. So again, if I come back here, if I push the tilde key, it swaps over. Because I have ever-changing data from that sensor that are in a at least reasonable range of values, I can make sure that the layout of, say, this bar chart and my labels are correct, that everything is doing what I want to do. And again, I can do it right from my desktop app. So by using simulation, we can greatly improve our efficiency as developers. We can get a lot of the application development done. We can simulate all of the different sensors that we might have right here on our desktop without having to have hardware. That means we don't have to lay out hardware, we don't have to do a bunch of soldering, and if you've got complex hardware, you may have multiple people on the team and not enough hardware to go around. Maybe you're ordering hardware, you're having a PCB laid out, and you want to do development before it arrives. There are a whole bunch of reasons that this speeds it up. That's all I've got for today. Hopefully you found it helpful. Remember, if you've got an idea, go out and build it.